Okay, now we will see what is meant by propagation constant and how to get attenuation constant as well as phase constants from the propagation constant. Right, so first we will define what it is and then we will derive it. Okay, fine. So the propagation constant comes from image transfer constant, which is the basic for getting propagation constant. So the image transfer constant of a symmetrical network is called propagation constant. Fine, that's why for transmission lines and all, we generally call the things with propagation constant, which is nothing but image transfer constant. So the image transfer constant is for a generalized network, whereas the propagation constant is for symmetrical network. Generally, the transmission lines are modeled as symmetrical networks, so there you can directly apply it. Fine, but how to get it? So we all know that e power theta I is equal to I1 by I2 square root of Zi1 by Zi2. So where theta is image transfer constant, but now we will replace that with propagation constant, considering it as a symmetrical network. So if it is a symmetrical network, Zi1 and Zi2 are equal, we already derived it, then it will be under root of 1. So that's why we are going to eliminate that. Then it will be e power gamma is equal to I1 by I2. Right, now we will see what is this gamma. How to get this gamma? It will be natural logarithm of I1 by I2. So what is this I1 here? So for a symmetrical network, we all know the input impedance is characteristic impedance, which is nothing but the terminating impedance. So I1 will be equal to V1 by Z0 if we consider V1 as the input voltage and V2 as the output voltage, then I2 will be V2 by Z0. So now Z0 will be cancelled. So we will get ln I1 by I2 is equal to ln V1 by V2. ln is nothing but natural logarithm. Fine. So that means we can have tan H gamma is equal to square root of ZSC by ZOC. So this has come from this relationship of image transfer constant. Okay, so I'm just replacing theta I with gamma, which is the definition of propagation constant. Right, so here we generally don't have Z2SC, Z1SC like that, because all are equal for a symmetrical network. So I have already told that, so it will be under root of ZSC by ZOC. Right, now here the gamma is a complex number, right, because we have phasors here, I1 by I2 all are complex numbers. So then gamma will also be a complex number. That means it is having a real part alpha and imaginary part beta, if we consider them as alpha beta. So here this alpha is given with a name and beta is given with a name, and alpha is known as attenuation constant, which is measured in Nepers, whereas beta is considered as phase constant and is measured in radians. We will see what are these alpha and beta. So right, Nepers are attenuation constant and radians are phase constant. So but how we get this? If you see this relationship where gamma is equal to ln I1 by I2, let us consider that relationship, or you can even consider ln V1 by V2. So here if you consider this alpha plus j beta is equal to ln V1 by V2, then how we can write this V1 by V2? Generally it is a phasor, so it is having a magnitude of V1 by V2 and angle of theta, which is given like e power j theta. Fine. Now if I separate this magnitude and angle into two parts, how we can do that? Since it is like a product, so ln V1 by V2 is one side and we have plus ln e power j theta. Right, now if I bring this j theta to the front, it will be j theta, and this is ln by ln v1 by v2. So that means we got here a complex number which is having some real part and also one imaginary part. That's why the units of beta are radians, because it is mapping with theta, which is angle, and alpha is Nepers, and it is also equal to ln magnitude of v1 by v2. That is important. So now onwards we will use alpha is equal to ln in magnitude of v1 by v2. Fine. Right, so it is like Nepers ln v1 by v2. Fine. right? So we have decibels. So dB is equal to 10 logarithm of p1 by p2 to the base 10, right? So it is with respect to decibels. So for decibels we consider logarithm to the base 10, right? So with this what we can write, p1, okay, first we will get p1 by p2. Here p1 by p2 is nothing but v1 square by z naught by v2 square by z naught, because zn is equal to z naught. So that means dB is equal to 10 log to the base 10 p1 by p2. If I replace that with v1 by v2 whole square, what do you get? 2 will come down and you will get 20 log to the base 10 v1 by v2, right? Fine. So this is nothing but decibels. So when this is decibels and this is nepers, we need to get a relationship between nepers and decibels. So it will be asked in the bits. It is very important. Fine. Okay, now we will see what is the relationship between these two. For that we will consider natural logarithm of p1 by p2 first, and then we will replace that with this product. So that means log a by a to the base b is nothing but log a by log b. You all know that. So using that condition, we can replace ln p1 by p2 equals to log p1 by p2 into ln 10. That means ln means log to the base e 10. So this is just a number value which is equal to 2.3026, and here log 10 p1 by p2 is nothing but we can get it into the relationship of decibels. So here 2n is equal to 2.3026 into dB by 10, because dB is 20 log 10 v1 by v2. So log 10 v1 by v2 will be dB by 20. So that is what coming from that to this, right? So if I simplify this, you will get dB is equal to 8.686 into nepers, that is nothing but n. Fine. So that means they are related like this. This equation can come directly in the bits, or it can be used for solving other design problems. Fine, that's it. Thank you.